Hi, I'm Chris, and in this video I will be walking through the process for designing and making custom topographic ornaments. The following is the simplest method that I found for doing this using free resources. And giving a quick overview of the tutorial, this video will involve creating the geographic outline in Inkscape, downloading STL elevation data online, using Tinkercad to cut the topographic data into the shape we want, 3D printing the models, painting them, and creating the final ornament with resin. The first step to this project is to create the outline of the shape that we want the end result to look like. To do this, I start by taking a screenshot of a map of the general location that I want, then copy and paste this into Inkscape. Now in Inkscape, I use the circle tool to create what will be the border for all of my ornament, except for the coastline. In the bottom left, I hold Shift and click the red box to add an outline to the circle, then click the X to remove the fill. Next, I fiddle around a bit to resize and realign the circle to encompass the area that I want, in this case all of Washington State plus a bit of ocean. For the coastline, I use the Bezier tool, specifically what Inkscape calls the B-spline path. With the snap to paths enabled, I create the first point directly on the circle, then start tracing. I'm given a pretty quick example here, but the basic process is creating as many points as needed along the coastline to get the general shape. I do this for the Washington coast and Vancouver Island. Once done, I duplicate each line using Ctrl-D, and while holding Shift, click the circle and use the Cut Path tool. This deletes the duplicate path and splits the circle where the lines cross. We can then delete sections of the circle that we don't want. Next, we need to join the paths together. If I select all of the paths, the Edit Paths by Node tool, then all of the nodes. If I click the Join Selected Nodes button to combine the overlapping nodes, we'll see some funky results. To make sure that this doesn't happen, you need to make sure that everything is a basic path by selecting the relevant objects and going to Path, Object to Path. Once you do this, you should get clean joining of the paths. The last thing in Inkscape you may want to do is resizing the outline to its actual size. This will simplify things a bit later on. In my case, my ornaments were about 62 millimeters in diameter, so that's what I resized the outline to fit. Next up is getting actual topographic data that we can use for 3D printing. There are a number of sources online for this, but I found Touch Terrain to be the best for its customizability with parameters. Using this tool, the first step is moving over to the area you want to get data for. And in my case, because my circle dips a bit into Canada, I need to change my data source to one that includes both the US and Canada. Then I increase the transparency and do my best to line up the box borders as near to the outline that we made in Inkscape as possible. This will make the next step easier. Now going through the options, I set the output size to the value closest to the actual size of my ornament. Then the two most important options for us are the base thickness and vertical exaggeration. Test out the parameters yourself to figure out what you like, but I use the default 1mm base thickness, then increase the vertical exaggeration to 30 times. And then you can download the file. Now we go to Tinkercad and use the outline that we created in Inkscape to slice the topographic data that we just got into the desired shape. The first step for doing this is creating a box bigger than the outline we will be importing. Then we import the SVG outline. Change it from a solid to a hole. Move it inside the box that we already created. Modify its height so that it's taller than the box. Select both objects, then click Ctrl-G to group the objects together. Next we import the topographic STL file that we downloaded and switch the grouped object from a solid to a hole. Now all that's left to do is aligning the topographic data with the outline as best as possible, and resizing the edges as needed. Personally, this is less accurate than I would prefer, but it is also hands down the simplest method that I found online for doing this. With everything lined up, deselect all objects and export the shape as an STL. The last step before we start making the actual design is prepping the file for 3D printing in your preferred slicing software. My preference is Cura. Of note, here you can scale the object to meet the final dimensions you want, in case dimensions were altered in the previous steps, or you want to change the height. You can also print at a pretty high layer thickness, as I personally don't think that thicker layers detracts from the final design. Next is 3D printing. We're finally making something. There's not much to note in this step. I will say that in my early experimentation, I used wood filament to see if I could stain these to have a wood appearance. After some testing, I decided that with these kinds of 3D prints, it wasn't really feasible to get a good stained wood look, so I moved over to painting instead. And so fast forward to now, I'm using wood filament that's getting fully painted over, so let's not judge that too harshly. My 3D prints had a lot of stringing. I briefly tried solving what was causing the stringing, but ended up just sanding them to remove the worst of the cosmetic defects, since this is getting spray painted over and won't be particularly visible. Next is painting the ornament, which I did in 3 steps. The first step is spray painting the base color. My favorite color ended up being a metallic copper spray paint. Then I used a textured moss paint that had particles in it that I thought looked well on the ornament for representing areas of vegetation. Lastly, I used a white paint for the mountains, using a dabbing motion from the top so that I only painted over the peaks. I used a blue dye to color the resin like the ocean. With the silicone molds I ended up using, the resin needed some help flowing into the thin space up top by the hole. But besides that, the resin pouring is pretty straightforward. I found in my first few tests that if you put the 3D prints on the resin shortly after they've been poured, it will sink somewhat into the surface. So while it's fun to show the future impacts of climate change, I wanted my land above the water. The solution for this is simply waiting 3 to 4 hours after mixing the resin to place the 3D prints. At this point, the resin is thick enough that the prints won't sink, but can still be stuck in the resin. After the 3D print has been placed in the mold, the last step I did was brushing on a clear top coat of resin, making sure that all surfaces got covered. Then blowing over the resin with a heat gun, because as you can see, I created a lot of bubbles when mixing the resin. And that's it. I hope you enjoyed this tutorial on how to make your own customized topographic resin ornament. Thanks.